This video includes different types of questions that can be asked from the chapter Polynomials of CBSE Class 9 students. Most of the questions in this video are taken from the sample papers issued by CBSE for the year 2019-20. So let's begin. Now let us see this question. Factorize using the factor theorem x cube plus 13x square plus 32x plus 20. Now what does factor theorem states? Factor theorem states that if x minus a is a factor of p of x, that p of x is a polynomial. If x minus a is a factor of p of x, then p of a must be equal to 0, and vice versa. If p of a is equal to 0, x minus a will be a factor of the polynomial p of x. So this is what the factor theorem states. So when you are asked to factorize using the factor theorem, we will have to find factors by substituting their values in the equation to get 0. So let us see, let us do by trial and error. So since the expression is containing all positive signs, all the signs are positive, therefore in order to obtain a 0, we should try substituting negative values. Otherwise we are never going to obtain a 0 because all the signs are positive here. So let us try with minus 1 first. Okay, so minus 1 the whole cube plus 13 into minus 1 square plus 32 into minus 1 plus 20. We will obtain it as minus 1 plus 13 minus 32 plus 20. Now this will be 12 minus 12, that is equal to 0. Therefore minus 1 is the 0 of the polynomial p of x. Therefore we can say that p of minus 1 is equal to 0. Hence x plus 1 is a factor of this polynomial. So we have obtained one factor of the cubic polynomial given here. We know that a cubic polynomial will have at most 3 factors. Now we know that this is a factor. Now we'll do long division with this factor and we'll obtain the remaining factors. So let us see. Let us divide the polynomial with x plus 1. By long division method, we are going to divide the expression with the obtained factor. So dividing with x plus 1, here it will be x square. X square into x will give you x cube. So the next term will be 1 into x square, that is x square. Subtracting, we will get 12x square. Taking this value here. Now in order to obtain 12x square, we have to multiply it with 12x. So you get 12x square plus 12x. Subtracting, what do we get? 0 plus 20x. Bringing this value here. Now in order to obtain 20x, we will multiply this with 20. So 20x plus 20 into 1 is 20. We know that the remainder will be 0 because x plus 1 is a factor, that we know. Therefore, it is obvious that the remainder will be 0. So now we have obtained a quadratic equation. Quadratic equation means a polynomial of power 2, of degree 2. Degree 2 means 2 will be the highest power in that polynomial. Such polynomials are called quadratic polynomials. So we have obtained a quadratic polynomial by dividing with x plus 1. Now we have to factorize this quadratic polynomial. So let us see. So we have already obtained one factor, that is x plus 1. Let us note it here. Now let us obtain the remaining factors by splitting the middle term method. So how do we find the factors of a quadratic equation? By splitting the middle term. We have to split this middle term into 2 parts, say a and b, such that the product of the 2 parts should be equal to the product of these 2. So here the coefficient is 1 and here it is 20. we'll take the product of the coefficients. So here it is x square, so the coefficient is 1, and the last term, constant term, is 20. So the product should be equal to 1 into 20, that is 20, and the sum should be equal to the coefficient of the middle term. So the sum should be 12. So we have to find two numbers such that their product is 20 and their sum is 12. So we know that the factors can be 4 and 5, and also they can be 10 and 2. So since the product is a positive value, either we'll use two positive factors, or we have two negative factors. So since the sum is also positive, we know that the values will be, of course, positive. Okay, so in order to obtain a sum of 12, we have to select these two values. So let us split up the middle term into 2. We have written 12x as 2x plus 10x. Taking common, x is taken common from the first two terms. We have x plus 2 remaining. 10 is taken from the second two terms. Again x plus 2 remains. So we have x plus 10 into x plus 2. So the factors of this quadratic term polynomial is x plus 10 and x plus 2. So and all the factors of this cubic expression can be written as x plus 1 into x plus 10 into x plus 2. So we have factorized this term. Now this is another question. Factorize 8x cube minus y cube minus 12x square y plus 6xy square. Here in the question it is not specifically said to factorize with factor theorem or any other method. So let us try first algebraic identities. It is very similar to the expression of a minus b the whole cube. Using the identity a minus b the whole cube, we can write a cube minus b cube minus 3a square b plus 3ab square. We know that this polynomial is very similar to the expression of a minus b the whole cube. So let us try rewriting it in this form. A cube, that is 2x the whole cube. 8x cube is written as 2x the whole cube minus b cube. B here is y minus 3a square b. A is 2x, so a square, b is y, plus 3a b square. So it will become 3 into 4, 12x square y, that is given here, and 6xy square. So this polynomial is given in the form of a minus b the whole cube. So let us rewrite it in that form, 2x minus y the whole cube. Hence the factors of this expression is 2x minus y, 2x minus y, again 2x minus y. This is how we factorize using the algebraic identities. And now this is another question. Find the value of x cube plus y cube plus z cube minus 3xyz if x square plus y square plus z square is equal to 83 and x plus y plus z is equal to 15. So we know that x plus y plus z the whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2xz. This is an algebraic identity. So let us substitute the values. We know that x plus y plus z is equal to 15. So 15 square is equal to x square plus y square plus z square is equal to 83 plus 2 into xy plus yz plus xz. So we can obtain the value of xy plus yz plus xz as 15 square, that is 225 minus 83 by 2. This value will be 142 by 2, that is 71. So we have obtained the value of xy plus yz plus xz. Now let us calculate the value of this polynomial. X cube plus y cube plus z cube minus 3xyz can be written according to the algebraic identity as x plus y plus z into x square plus y square plus z square minus xy minus yz minus xz. Now we know the value of x plus y plus z, that is equal to 15. We also know the value of x square plus y square plus z square, that is 83, and we know the value of xy plus yz plus xz. So let us substitute this value. Minus 71. 83 minus 71 is 12 into 15. So 12 into 15, we have the value as 180. Now this is another question from the CBSE sample paper. Evaluate 99 the whole cube. We know that it is better to use the algebraic identity rather than multiplying 99 3 times. So in order to obtain this in the form of an algebraic identity, we will express 99 as 100 minus 1. Therefore 99 the whole cube is given as 100 minus 1 the whole cube. So a minus b the whole cube is given as a cube minus b cube plus 3 a b square minus 3 a square b. So on expanding we get 100 the whole cube minus 1 plus 300 minus 30,000. So we have two negative terms and two positive terms. Let us add the positive terms first. Let us add the positive terms first. 10 lakh plus 300. 8672. Okay. Minus 30,001. So we'll obtain the value as 970299. Find the value of x cube plus y cube minus 12xy plus 64 when x plus y is equal to minus 4. This is given. Okay. So this is another question. Find the value of this polynomial if we know that x plus y is equal to minus 4. You can see that this expression contains three perfect cubes and another term minus 12xy. Therefore, it is comparable to the expression of a cube plus b cube plus c cube minus 3abc. So this is comparable. So these two expressions are comparable to each other. Hence, let us rewrite it as x the whole cube plus y the whole cube plus 4 the whole cube minus 3 into x into y into 4. So a cube plus b cube plus c cube minus 3abc can be given as a plus b plus c into a square plus b square plus c square minus ab minus bc minus ac. Now let us substitute the value of x plus y. So minus 4 plus 4 into this term. We know that minus 4 plus 4 is 0. Therefore, the value of this expression is equal to 0 if x plus y is equal to minus 4. Find the value of k if x minus 1 is a factor of the given factor of k x square minus 3x plus k. So according to the factor theorem, if x minus a is a factor of p of x, p minus a should be equal to 0. So using that, if x minus 1 is a factor of this polynomial, we can say that p of 1, that is k of 1 square minus 3 into 1 plus k should be equal to 0. Therefore, k minus 3 plus k is equal to 0 to k is equal to 3. Hence, k is equal to 3 by 2. Calculate the perimeter of a rectangle whose area is given as 25x square minus 35x plus 12. Okay, so we know that area of a rectangle is equal to length into breadth. So if we can express this polynomial in the form of two terms, then that forms the expression for the length and breadth. So let us factorize this first. 25x square minus 35x plus 12. We have to obtain two numbers such that their product is equal to 12 into 25 and their sum should be equal to minus 35. Here the be 300 and the sum should be minus 35. Which are those two numbers? The numbers are 15 and 20. Okay, so both the numbers should be negative. So let us split up the middle term as minus 15x and minus 20x. Taking 5x common, we have 5x minus 3. Here also taking 4 common, we have 5x minus 3. So 5x minus 4 into 5x minus 3. So we have expressed the polynomial given for area like this. So we can assume these are the length and breadths of the polynomial. Now what is the expression for the perimeter? The expression for perimeter of a rectangle is 2 times L plus B. So 2 times the expression for length and breadth are 5x minus 4 plus 5x minus 3. That becomes perimeter is equal to 2 times 10x minus 7, 20x minus 40. Evaluate 104 into 96 without directly multiplying the terms. Here we know that using algebraic identities we can express 104 as 100 plus 4 and 96 as 100 minus 4. Now the expression has become a plus b into a minus b. Therefore we can write it as 100 square minus 4 square. That is 10,000 minus 60. We get the value as 9984.
So that's all. We have discussed 7 different types of questions from the chapter. So if you like the video, please don't forget to like, share and subscribe to my channel. Thank you for watching the video.